Hello, welcome back to Learning from Ms. H. We're going to do Earth Science, a lesson on the moon today. For your bell work, go ahead and think about what you know already about moons in general and our moon in particular, and write a paragraph or two explaining what you already know or think you know. Once you've done that, go ahead and restart the video and go through today's lesson. So pause, take a minute, jot down your bell work, and I will see you back here in a minute. All right, for today's lesson, we are going to go through a slideshow presentation about the moon. You're going to read through the slides. You can go through them with me on the video. Make sure you're taking notes about this in your notebook. If you are virtual, you can do it in a Google Doc if that's how you're taking notes. My preference is the notebook because nothing really replaces the value of actually handwriting these as far as helping you learn. Once you're done with the notes, go ahead and scroll down, work on the homework. So let's jump in. As always, when we're going through the slides, if I'm going too fast for you, which I probably am, pause the video, finish the slide you're on, and then restart the video. If I left wait time on these for everybody, I'm afraid these videos will be too long for you. So just pause anytime you need to, and then press play to carry on from there. Go ahead and pause me and gather up what you need to write in and on to take notes. All right, let's get started. So we're going to be talking about the moon and some of its main vocabulary today. You should have these words in your vocabulary already. If it's not done, this is a great way to double check and get those definitions. If it's done already, just make sure you have definitions that match up to this or are close to this. Here we go. So general characteristics of the moon. Its density is much similar to Earth's mantle rocks. That's actually how scientists came up with the theory of the beginning of the moon, where it came from, which we'll talk about in a minute. So its density is very similar to the mantle rock of Earth. It's obviously cool and solidified, whereas the mantle is still hot, molten rock. But that does not affect the density. So that's density matching is kind of an interesting characteristic. The moon has a lower albedo than Earth does. Albedo means that it reflects less light. So albedo is how much light is reflected. Since it's lower, it reflects less light than the Earth. Gravity on the moon is also less. It has about 1/6 the gravity of Earth. So if you had a 150-pound person on Earth and you transferred them over to stand on the moon, they would only weigh about 25 pounds on the moon. Again, that's weight, not mass. So their mass is going to be the same, the amount of stuff that makes them up, all of the matter that is contained in their body, that's all going to be the same. So a mass of 10 on Earth is a mass of 10 on the moon. However, remember that weight is a function of the pull of gravity on mass, so that's why it changes. The moon has extreme temperature ranges. There's no atmosphere on the moon, so there's nothing really to regulate the temperature. So on the sunny side of the moon, it can get up to 250 degrees Fahrenheit. On the dark side of the moon, it gets down to 250 degrees negative. So you've got a 500-degree temperature swing there. Negative 250 on the dark side to positive 250 on the light side. And again, the reason for that change is because you have the sun's rays hitting one side but not the other. So we talked about the fact that there's no atmosphere, and that's why there's such a range of temperature extremes. There's also no flowing water and no tectonic forces. So there's no earthquakes, there's no volcanoes, there's no core spinning in the middle like we have. It's basically just a solid chunk of rock. The only way that the landscape of the moon changes is if it gets hit from other things floating around in space. And that's where all of its craters and features came from. It's covered in what's known as regolith. That's a loose blanket of dust and rock that's held in by the small amount of gravity that the moon has. It's also marked by rilles, which is the long, narrow depressions, and there's images of this on the right. So you've got one of those long, narrow depressions right here. And then all of this along the surface here is going to be the regolith. It's moon dust, moon dirt, basically. The regolith is what was collected to be tested for that we call the moon dust. These circular features are going to be craters, and we'll talk about how they came about here in a minute. Impact craters. So you have these large circular areas, depressions. They're varying sizes from a few feet to hundreds of miles. And they're basically created by asteroids and meteoroids that strike the moon. There's all kinds of space debris out there that are floating through space and run into the moon, and since it does not have the atmosphere, they don't burn up like they do when they come into contact with Earth's atmosphere. So they're going to make the craters on the moon. And a 10-foot meteoroid can make a 500-foot crater. And it's all based on how hard it hits. So when you're looking at a crater, this is a depression on the moon. Something has come in and hit the moon and made this depression. You've got this central peak in the middle here. It's a little raised area that's caused basically by rebound. So when you push the surface in so much, it's a little cone area that comes back out. Ejecta is all of the material that's ejected from the crater. So all of this, basically the splash zone out here. Think about when you do a cannonball into a pool, all of that water that's displaced and splashes up. That's similar to the ejecta. And then the rays are the splash marks that radiate outward. So they go past the ring of ejecta here and shoot out. So this is a ray out here. And it goes out and away, just like a ray of sun when you draw a sun on a piece of paper. So how did the moon form? The going theory is that an object roughly the size of Mars that they named Theia came into contact with the Earth. So it smacked into the Earth, and when it hit, it caused a large amount of material to be ejected from the surface of the Earth. All of that material was kept in the Earth's atmosphere and in the space around Earth's atmosphere because of the gravity of Earth. Kind of like the rings of Saturn, except there was enough of it that it all coalesced and formed a solid rock, which is now known as the moon. They call it the giant impact hypothesis, and they also think that this is the reason that Earth's axis is off center, because when the impact hit, it knocked us off kilter a little bit. So here's the giant impact hypothesis in image form. You have Theia, which is the Mars-sized object coming in. It smacks into Earth right here, shoots off all the debris. The debris is circling around the Earth here, similar to the rings of Saturn. And then over time, the gravitational pull gets all of that debris to come together, coalesce, and form a solid rock that is now the moon. So there's 4 stages of the history of the moon. The original crust, when everything came together, formation of the Lunar Highlands, the Maria basins, and the rayed craters. This animation here was posted by NASA. It's the theory of how that might have happened. So pause me, go to slide 10 in your presentation, take a moment and watch this presentation, and then restart the video. Okay, so that was a short animation of the theory of the formation of the moon, what scientists think happened, um, and what it would have looked like with all of those objects bombarding the moon all at the same time over millions of years. So, formation of the original crust. Scientists believe that it solidified roughly 4 billion years ago, shortly after the Earth was formed. So you would have had Earth forming, and then Theia hit, Earth heals itself, the moon coalesces. And because the moon is thought to have come from the Earth, or because the moon rock matches the mantle density, they believe that it came from the Earth in this way. So Lunar Highlands, just under 4 billion years ago, you had lots of meteors and asteroids bombarding the moon, just impact after impact. And you can see in some of these, they're relatively clean, so they are fresh impacts. But others, you have larger impacts with smaller impacts inside them. So you can see the multiple layers of impacts over time. Each circle on here would be an impact from some type of space debris. The Maria basins. These are thought to have formed between 3 and 4 billion years ago. These are going to be large impacts. These craters are filled with basaltic lava. Again, it is all solid and there is no actual volcanic activity. So these were formed from larger impacts, not from surface volcanoes. They believe this is what happened because on the far side of the moon, there are no Maria. They're all on this one side. So this was probably some type of meteor shower that all came from one direction and had these large objects that hit all together from the same direction. Rayed craters. So you can see this one a lot more clearly than in the previous picture. You've got the crater here, you've got the ejecta field here, and then you have all of these rays coming off, all of these streaks coming off. It almost looks like somebody tried to draw a sun right there. So these are going to be recent impacts within the last billion years. The rays are material that's being thrown out past the ejecta field, and they're going to be lighter in color because they're younger. So they'll have a higher albedo because they'll reflect more light. And we know they're younger because they don't have all of the additional impact craters on top of them yet that most of the others do. All right, so that is it for the notes for today. If you scroll down here, you've got the moon homework. So let's click on that and take a look and see what it is. It's going to be a quiz form for you to fill in. This is really just a worksheet. You have unlimited number of attempts on this. So make sure that you work on this. Do it as many times as you need to. Use your notes to answer questions. If you need to figure out how to use quizzes, you can check out the guide on it. I will publish this so you can see it. And once you're done with this, you are done for the day. I will see you next time.